Good day, people. In this video, we're going to look at scale diagrams, both enlargements and reductions. Let's go. So a diagram that is an enlargement or a reduction of another diagram is called a scale diagram. Okay, and the scale factor is basically the relationship between the matching lengths on the two diagrams. And you can see an example right here of a scale diagram. Okay, so we have the original here on the left and then a scale diagram on the right. And as you can see, the scale diagram has in fact enlarged. So let's look at what this example entails here. So the main thing you have to remember is this little bit right here. So the scale factor is going to be the length on the scale, okay? So the scale diagram over the original, okay? Scale over original, and this applies for both enlargements and reductions. Now, let's look at an example here. So if I'm trying to find the scale factor, I need to put the length of the scale diagram on top, okay? So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So if we've got 9 on the top in the scale, it's right up here, and 1, 2, 3 right here. Okay, so I'm going to go 9 on the top, 3 on the bottom. 9 divided by 3 equals 3. So the scale factor in this case is 3 times as big. Okay, now just to double check, if I'm looking at here, like the width side, I've got 2 blocks. Down here on the scale diagram, I've got 1, 2, 3, 4, 5, 6. So 2 times the scale factor, which is 3, is going to give me 6. Okay, just like here where the length is 3, 3 multiplied by the scale factor is going to give me 9 on this length. All right, so that's an example of the scale factor enlarging. Okay, moving on. Let's take a look at a word problem here dealing with enlargements. So we have a photo that measures 10 centimeters by 15 centimeters, and we're going to make the enlargements with the scale factors identified here below, which is a scale factor of 4. Okay, and it asks us to find the dimensions of each enlargement. So let's look at the length of the original photo. The length of the original photo is 15 centimeters. Okay, so if we're blowing it up, making it bigger, okay, we're going to multiply that by 4 because that's our scale factor. So if we say 4 times 15, we're going to get 60 centimeters for the length of the enlargement. And the width, you just do the exact same thing. It says here 10 centimeters for the width. So if we're identified at 10, then we're going to say 10 times 4. We're going to say 10 times 4 for our width. And of course that gives us a width of 40 centimeters. So the new size of our photo is actually going to be 40 centimeters by 60 centimeters. Okay, so you're increasing it by a scale factor of 4. All right, so let's look at an example here now where we are doing a reduction. Again, we're still referring to scale diagrams. We have our original here and our scale diagram here. As you can see, the scale diagram in this case is not getting bigger. It's quite a bit smaller, in fact. Yet our scale factor, quote unquote, formula remains the same in that the length of the scale diagram is divided by the length of the original. Okay, so it's always scale over original. So if we were to look at the original rectangle, we're going to see here that we've got, if I just go lengthwise, 1, 2, 3, actually I'll go widthwise on this. It doesn't really matter. Now let's go length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's the original. And then of course the scale, which is much smaller, 1, 2, 3. So we're going to go scale over original. So it's actually going to be 3 over 12. Okay, and when you're reducing, your answer is typically going to be in fraction form or decimal form, okay? And if we were to divide this, you can leave it in lowest form as a fraction, which would be 1 because 3 goes into 3 once and 3 goes into 12 4 times. It could be 1 4. Or we could just use a calculator if you like and divide 3 over 12 and it'll spit you out a decimal, which is going to be 0.25. So this is a quarter of the size of the original. Okay, so the scale factor you could say is 1 over 4, or you could say it as 0.25. So it's the exact same as enlarging, except of course the numbers are going to be a little bit foreign looking because they're going to remain in fractions or decimals, okay? Because we're actually decreasing in size, where scale factor is going to be small. Alright, this is our last example of the video. This one we're looking at circles and dealing with diameters here, okay? So the same thing applies. Our scale factor is going to be the diameter on the scale diagram over the original, okay? Just like always. Now, if I look at my original, I'm going to see that I've got 1, 2, and this looks like about 0.5. Okay, so I get 2.5 diameter. Now, diameter is the distance across the circle going through the center of the circle. Okay, half the distance is referred to as the radius. Okay, so we got a diameter here at 2.5, and the diameter here from endpoint to endpoint is 1 centimeter. So when I work out my scale factor for this, it actually comes out to be 1 on the top. Oops, sorry, my pen here. Okay, so we've got scale of 1, and on the bottom we've got the diameter of the original, which is 2.5. So 1 over 2.5, and you can use your calculator and figure that this is 0.4. Okay, so the scale factor in this case is 0.4. If you're looking through your Math Makes Sense workbook on page 269, you'll see this example there. And the answer key actually has it wrong. They used 0.5 as the diameter on the scale diagram, but as you can see, they must have accidentally plugged in the radius measurement because the diameter is the width across. So that turns out to be 1. Okay, so 1 divided by 2.5, we get a scale factor of 0.4. And that's all for this video, guys. Good luck on your quiz, and see me if you need any extra help. Take care.